Ever struggled with CPU-heavy tasks, freezing your entire application while the event loop grinds to a halt? You'll see exactly how to wrap blocking operations in FastMCP tools using AnyIO to thread, run sync, keeping your server responsive while still handling intensive computations. The pattern ensures your AI tools stay performant, even when crunching numbers or processing large datasets.
Import AnyIO. From FastMCP, import FastMCP. MCP equals FastMCP. Def CPU intensive task data, SDR. Hash some heavy computation that could block the event loop. Return process data. At MCP, tool. Async def wrapped CPU task data, SDR. CPU intensive task wrapped to prevent blocking. Return await AnyIO to thread. Run sync, CPU intensive task data.
This demonstrates the async offloading pattern for CPU-bound operations in event-driven systems. The core concept is isolating blocking work from the main event loop by delegating it to a separate thread while maintaining an async interface for the caller. What makes this distinctive is how it preserves the async contract while transparently handling sync work, letting you write natural Python without callback hell or manual thread management. The pattern works by decoupling execution context from interface contract. The async wrapper function serves as a bridge. It accepts the async call, dispatches the sync work to a thread pool via AnyIO to thread, runs sync, then resolves the future when complete. This maintains non-blocking behavior for the event loop while still leveraging existing synchronous code, and the Decorator approach keeps the offloading logic declarative rather than imperative. This matters because it solves the classic async I/O bound versus CPU bound tension without forcing you to rewrite legacy code or abandon synchronous libraries. You get the scalability benefits of async I/O while still using CPU-intensive functions, and the pattern is particularly valuable in AI tooling frameworks where tools must remain responsive during heavy computation. The trade-off is thread pool overhead, but for most CPU-bound tasks, the simplicity outweighs the cost. Let's break it down line by line.
Import AnyIO.
This imports AnyIO, a library for cross-platform async, I/O, and thread pooling. It enables offloading CPU-bound work to separate threads, preventing event loop blocking in async applications.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI callable tools. It transforms Python functions into structured tools that AI models can invoke, handling serialization, validation, and execution.
MCP equals FastMCP.
Instantiates the core FastMCP controller. This single instance manages all AI callable tools and handles the connection lifecycle to the MCP server.
Def CPU intensive task data, SDR.
This defines a synchronous CPU-bound function that performs heavy computation. It's intentionally blocking, demonstrating the type of workload that would normally freeze an async event loop. The wrapper function will offload this to a thread pool to prevent blocking.
Hash some heavy computation that could block the event loop. Return process data.
This placeholder represents blocking CPU-bound work that would freeze the event loop. In async Python, long-running computations must be offloaded to threads, which is exactly what the wrapper function handles next.
At MCP, tool. Async def wrapped CPU task data, SDR. CPU-intensive task wrapped to prevent blocking.
This Decorator exposes wrapped CPU task as an AI callable tool while preserving async compatibility. The @MCP tool wrapper generates OpenAPI schema from type hints and docstring, and FastMCP's runtime handles the async execution context. This pattern keeps CPU-bound work non-blocking without sacrificing tool discoverability.
Return await AnyIO to thread. Run sync, CPU-intensive task data.
This offloads the CPU-bound work to a separate thread, preventing event loop blocking. AnyIO to thread, run sync, handles the thread management and awaitable conversion, ensuring async compatibility for synchronous functions. Critical pattern for mixing CPU-heavy tasks with async I/O. Blocking operations in FastMCP. That MCP tool Decorator transforms synchronous CPU-bound work into non-blocking async operations by offloading execution to thread pools. Missing await on the wrapped function silently defeats the purpose, running the CPU task in the event loop and causing server hangs. Always verify thread pool usage with AnyIO to thread, run sync, or equivalent for true non-blocking behavior.
The thread that disappears from view carries the heaviest load.